6 trucks loaded with discarded cables arrive at the factory gates. What the world threw away is about to become something few people would ever believe. 30 tons of electrical scrap in every truck. The unloading begins. Within seconds, mountains of tangled cables appear. Hidden inside that chaos lies one of the most valuable materials in the recycling industry: copper. Cables from demolished homes, abandoned factories, construction sites, entire electrical systems stripped from buildings that no longer exist. Beneath layers of plastic, dirt, and corrosion sits copper as valuable as the day it first left the smelter. Massive loaders plunge into the tangled piles and tear away tons at a time. Every scoop contains thousands of dollars worth of recoverable metal. 3 machines feed the production line without stopping, hour after hour. The factory consumes scrap at an astonishing rate. This is Copper Forge Company, where electrical waste is transformed into some of the world's most desirable copper cookware. But before the metal can be melted, purified, or shaped, the factory faces its first challenge: separating value from waste. The sorting process begins. Powerful electromagnets lift the thick industrial cables away from the lighter residential ones. Different cable types follow different processing routes. Outside, they all look the same: dirty, damaged, worthless. Inside, the story is completely different. Experienced workers inspect every bundle. Years of practice allow them to identify copper grades with a single glance. A quick look at a cable reveals everything: purity, composition, value. What began as a chaotic mountain of scrap slowly becomes an organized flow of material. Only the highest quality copper is allowed to continue. Then comes the shredder, 3 meters of reinforced steel designed for destruction. The cables disappear into the machine. Nothing that enters will ever leave in the same form. The blades show no mercy. Plastic explodes apart. Copper fractures instantly. Entire cables are reduced to fragments within seconds. In a fraction of a moment, the cutting blades expose the reddish metal hidden beneath years of insulation. The copper is finally free, but the work is far from over. Thousands of fragments emerge from the shredder. Copper and plastic still mixed together, now they must be separated. A vibrating separation table begins the next stage. Here, physics takes over. Copper is heavy, plastic is light. Gravity reveals the difference immediately. As the table vibrates, dense copper particles move in one direction. Lightweight plastic moves in another. No chemicals, no complex machinery, just weight and motion. Then powerful jets of compressed air sweep across the material. The final traces of plastic are blown away. Only pure copper remains. A shower of clean copper falls into collection bins below, ready to face temperatures exceeding 1,000 degrees Celsius. Raw copper, bright, reddish, unrefined. The same metal that only hours from now will become luxury cookware. Hundreds of kilograms accumulate rapidly. The furnace is waiting. Even the plastic is not discarded. It is compressed into bales and sent for recycling. Nothing leaves this facility as waste. Nothing. Before the copper can continue, one final test remains: X-ray analysis. The purity must be exact. Every batch is scanned, every impurity identified. Dirty cable enters one side of the process, pure copper exits the other. Recyclable plastic follows its own path. Apart from the original scrap, nothing is lost. Now the copper moves toward the hottest place in the entire factory, the foundry, a controlled industrial inferno where solid metal becomes a river of liquid fire. More than 1,000 degrees Celsius, and the beginning of copper's second life. The purified copper travels directly from the separation line to the furnace. The flow never stops, the process never pauses. Granule after granule disappears into the glowing interior. Cold copper enters, liquid metal will emerge. Even before reaching the bottom of the furnace, the heat begins to transform it. The color changes first, then the structure itself begins to surrender. At exactly 1.085 degrees Celsius, copper reaches its melting point, the moment solid metal gives in to heat. Only an hour ago, these were fragments of discarded electrical cables. Now they form a glowing lake of molten copper, a sea of liquid metal shining like gold, more than 1,000 degrees Celsius. Pure energy, pure heat, pure transformation. But even now, the copper is not ready. Impurities float across the surface like dark islands. They must be removed. Compressed air is injected directly into the molten metal. The oxygen triggers a reaction. Contaminants oxidize and rise to the surface. The purification process begins. Slowly, the dark layer of slag is pushed aside and removed. Pass after pass, the black waste disappears. What remains beneath becomes brighter, cleaner, purer. Every minute increases the quality of the metal, until finally, nothing remains except molten copper, clean, refined, ready for its next form. The furnace begins to tilt, slowly, carefully. Tons of liquid metal start moving toward the outlet. A river of molten copper emerges, glowing, brilliant, flowing like controlled lava. The stream travels through refractory channels toward a line of waiting molds. The first mold fills, then the second, then the third. Molten copper begins taking on a solid shape once again. Mold after mold fills in sequence. Dozens of copper ingots are born from the same river of fire. The transformation begins immediately. The brilliant golden glow slowly fades, the surface darkens, the metal cools. For the first time since melting, copper begins to crystallize. A new structure forms inside every ingot. The cooling process is carefully controlled. Too fast and defects appear. Too slow and production suffers. Every second matters. Granules of scrap enter the furnace. Pure copper ingots emerge from the other side. The foundry has completed its work. The metal has been reborn. But the journey is far from over. The ingots now begin their second transformation. A luxury cookware set cannot be made from solid blocks of copper. The metal must first become something completely different. A sheet. A thin, flexible sheet capable of being shaped into cookware. Before rolling can begin, the ingots must be heated again. A preheating furnace raises their temperature until they glow cherry red. At this point, copper becomes dramatically softer, almost like clay. The glowing ingots leave the furnace at high speed. Ahead waits one of the most powerful systems in the factory. 6 pairs of rolling mills, each set tighter than the last, each one designed to squeeze the metal thinner. The first rollers grab the glowing copper without hesitation. The ingot is crushed, stretched, flattened. Every pass changes its shape. Every pass reduces its thickness. Every pass pushes it closer to its final form. The copper loses thickness, but gains flexibility. A thick block gradually becomes a sheet. 1 pass, 2 passes, 3 passes, 6 complete stages. The transformation is extraordinary. What entered as a massive ingot now behaves almost like fabric. A sheet of metal thin enough to bend, strong enough to last decades, bright, smooth, uniform. The final rollers release a continuous copper sheet. The surface shines under the factory lights. The metal flows forward like a river, but now it is solid and perfectly controlled. Laser scanners inspect every centimeter. Thickness measurements occur in real time. Every fraction of a millimeter matters. A cookware set can only perform correctly if every wall has exactly the right thickness. Anything outside specification is rejected. The sheet continues moving toward the winding station. Meter after meter of copper is rolled into massive coils. Each coil contains hundreds of kilograms of metal. Each rotation adds dozens of future cookware pieces. The coils grow larger, heavier, more valuable. Stored together, they represent an inventory of future luxury cookware waiting to be born. Ingots entered one side of the rolling mill. Copper sheets emerged from the other. In only a few minutes, solid blocks of recycled metal have become something entirely new. a metal fabric ready for shaping. The copper coil is mounted onto the cutting line. Every meter of sheet metal contains the potential for dozens of future cookware pieces. The copper moves forward under precise tension, flat, smooth, perfectly controlled. Every centimeter is measured before the cutting process begins. Then comes the first strike. A sharp, metallic impact echoes through the factory. A perfect copper disc drops from the sheet. The exact beginning of a future pan, a future pot, a future piece of luxury cookware. Disc after disc is punched without interruption. The process never stops. The skeletal framework left behind is immediately collected and returned to the furnace. Nothing is wasted. Nothing is thrown away. A flat copper disc emerges. Simple, perfectly round, bright, and deceptively ordinary. Within seconds, that disc will undergo the most dramatic transformation of the entire manufacturing process. The hydraulic press is waiting. The disc is positioned over a precision mold. Everything that happens next depends on this moment. One mistake would destroy the metal. One mistake would ruin the product. The press begins to move, slowly at first, then with overwhelming force. The copper yields. The flat disc stretches downward. The metal flows into shape. For the first time, the unmistakable form of a cooking pot appears. Every millimeter of depth means another millimeter of cookware. The copper stretches to its limits without tearing, without cracking, without failing. The press, and there it is, still rough, still unfinished, but unmistakably a pot. A robotic arm removes it from the mold and transfers it to the trimming station. Here, precision cutting tools remove excess material. The edges are cleaned. The walls are refined. A forming roller curves the rim into its final profile. The transformation continues. The cookware begins to look real. The proportions are correct. The walls are uniform. The shape is complete. But something is still missing: shine, protection, and the feature that makes copper safe for cooking. Because pure copper has one major problem: it cannot safely come into direct contact with food. Without protection, copper reacts with ingredients during cooking. That is why every piece must receive an interior lining. A blue flame heats the copper to the exact temperature required. Then comes a process that has remained largely unchanged for centuries: tin lining. A solid block of tin touches the heated copper. Instantly, it begins to melt. Liquid silver spreads across the interior surface. An experienced craftsman takes over. Even today, no machine has fully replaced this step. The molten tin is guided by hand, spread evenly, controlled carefully, balanced perfectly. Centuries of tradition preserved inside a modern factory. Two metals become one. The tin seals the copper, protecting food, protecting flavor, making the cookware safe for everyday use. Silver on the inside, copper on the outside. The cookware is now functional, but it is not yet complete. It still needs handles. Bronze bars arrive at the forging station, measured to exact dimensions with precision. This is the material that will complete every piece. The forging press strikes. A single impact shapes the bronze into an ergonomic handle, designed for the hands of professional chefs. Strong, comfortable, elegant. The forged handle is positioned against the copper wall. Now comes the permanent connection: welding. An electric arc flashes. The filler metal melts instantly. Copper and bronze become permanently joined. A seam designed to survive decades of use. The second handle follows. Now the cookware finally appears complete. Copper, tin, bronze, three metals working together as one. The welds are inspected carefully, clean, precise, strong, built to withstand thousands of cooking sessions. The cookware now functions exactly as intended, but visually, it still looks unfinished. The surface remains dull. The color lacks depth. The shine does not yet exist. Ahead waits the final transformation: the polishing room, the place where industrial metal becomes luxury. Hand-lined interiors, forged bronze handles, precision welding. Everything is complete except the finish, and that finish will change everything. The polishing room, the final stage of transformation. This is where a dull piece of industrial metal becomes an object of luxury. Rows of unfinished cookware move toward a series of polishing stations, each one carrying the same potential, each one waiting for the moment everything changes. The cookware begins to spin. A large polishing wheel moves closer. The first contact changes everything. The wheel touches the copper. Instantly, the dull outer layer begins to disappear. The shine hidden beneath starts to emerge. Microscopic scratches vanish one by one. The copper grows brighter with every second. More reflective, more vibrant, more alive. Dozens of pieces are polished simultaneously. Fine copper dust floats through the air like golden glitter. The room glows under the factory lights. A second polishing stage follows, this time using a finer compound. The transformation becomes dramatic. Warm metallic shine becomes a near-perfect mirror finish. The copper reflects everything around it. Machines, workers, lights. The entire factory appears on its surface. What began as discarded electrical cable now looks more like jewelry than cookware. The bronze handles receive the same treatment, polished until they shine like gold. Every detail matters. Every surface matters. Perfection is the standard. Then comes ultrasonic cleaning. High-frequency sound waves remove every invisible trace of polishing compound. Nothing remains. The result is extraordinary. Mirror-finished copper on the outside, brilliant silver tin on the inside, golden bronze handles at the sides, 3 metals, 1 luxury object, a jewelry-grade finish created from recycled industrial waste. Yesterday, it was scrap. Today, it looks like a museum piece. A laser engraving system marks the base, Copper Forge Company, a permanent signature, proof of origin, proof of craftsmanship, proof of transformation. Dull cookware enters the polishing room. Mirror-finished luxury leaves it. The journey from cable to cookware is almost complete, but one final challenge remains: quality control. Every piece must survive 5 separate inspections before earning the company seal. The first test measures copper thickness. The second measures the tin lining. Both must fall within extremely narrow tolerances. Anything outside specification is rejected. The third test targets the handles. Enormous force is applied. The cookware must withstand years of professional use without deforming, without loosening, without failure. The fourth test measures thermal performance. Heat moves through the copper wall almost instantly. Only silver conducts heat more efficiently. That is one of the reasons professional chefs continue to prefer copper. The final test evaluates the complete product. Appearance, dimensions, balance, finish. Everything is inspected. Everything is verified. 5 tests completed, 5 tests passed. Only now does the cookware earn the Copper Forge Company seal. A gold emblem is applied, alongside a unique serial number. No 2 pieces are exactly the same. The luxury experience begins long before cooking. White gloves carefully wrap every piece in protective fabric. Every movement is deliberate. Every detail considered. The black presentation box waits nearby. Soft velvet lining, gold logo, certificate of authenticity. The first thing the customer will see: the cookware that began life as discarded cable now resembles a luxury timepiece. A collector's item, not a recycled product. Robotic systems stack the boxes with precision. Every package receives a QR code, a digital record of its entire journey. From scrap cable to finished cookware, thousands of premium boxes wait inside the warehouse, ready to cross oceans, ready to enter some of the world's most demanding kitchens. Tested, certified, packaged, and protected by a lifetime warranty. The journey continues. As dawn breaks across Europe, shipments begin arriving at their destinations. Luxury kitchen boutiques, professional cookware retailers, specialty culinary stores. The black boxes are unloaded. The journey is nearly complete. Under showroom lighting, the copper shines like precious metal. Customers stop and stare. Few would ever imagine where it began. No one sees the electrical cable hidden in its past. Only the beauty that exists now. A chef lifts one from the display, comparing it to every other option available. The decision is easy. Copper responds instantly to heat. No hot spots, no uneven cooking, just perfect thermal control. A sauce begins to simmer. The heat spreads uniformly across the entire surface, exactly as professional chefs expect, exactly as copper has done for centuries. The price tag reads $400. Yesterday it was electrical waste. Today it is a luxury object, a product desired around the world. Copper Forge Company. From the cable the world discarded to the cookware the world desires. Because copper never truly dies, it simply begins again.